In this example, I'd like to look at solving an exponential equation when I've got a fraction involved as the base of one of the powers, meaning I'm going to need to use a negative exponent in order to write this as a common base on both sides. So if I look at 1 over 8, I want to focus on the denominator here of 8, and I want to focus on 16. So when we think of powers of 2, 2 times 2 times 2 is 8. So 2 to the 3 would be 8. And if I just add an extra 2 in on that, then I'm going to get 2 to the 4 is 16. So I know the powers I'm going to need to use. I just need to make sure that the sign on my exponent is correct. So because I've got 1/8 here instead of just 8, that's not going to be 2 to the 3. It's going to be 2 to the negative 3. And you'll notice that the exponent from the first part of this equation stays the same. Also, 16 would be written as 2 to the 4. Don't need a negative here because this wasn't a fraction when I started. So now you see I have a common base on both sides. But what I also have is a power of a power. So recall that when we have a power of a power, exponent laws dictate that we need to use a distributive property to multiply the two exponents. So in this case, I would be multiplying x minus 3 by negative 3. So I would have 2 to the negative 3x plus 9. And on the right-hand side, I would have 2 to the 8x plus 4. Now we know that the only way that these two can be equal would be if the exponents are equal. So now I'm going to equate the exponents. So I'd say negative 3x plus 9 is equal to 8x plus 4. Now I'd like to keep my x values or terms positive if I can, so I'm going to be moving negative 3x to the right-hand side, and I'm going to be moving the 4 to the left-hand side. So I'd have 9 left over here, and when I move the 4 over, I'll be subtracting it. And I've got 8x, and when I move the negative 3 over, I'll be adding that. So now I have 9 minus 4, which gives me 5, and 8 plus 3 to give me 11x. So then dividing by 11, I would have 5 over 11 equals x.